Hey everybody, this is Mr. K. We are now moving on to the next lesson for this week, and it is all entirely on geometric sequences. And this I don't believe we went over in class, but it's really easy. So you might remember the word sequences. And that's when we covered arithmetic sequences. You might remember that with some horror and go, oh no, arithmetic sequences, that's terrible. Well, it actually wasn't. Let's recall that a sequence is just a list of ordered numbers. So, you want to find out what the next number is in order. So if the numbers are 1, 3, 5, 7, 9, 11, what you might notice is that this is actually an arithmetic sequence right here where we keep going up by 2 every time. So plus 2, plus 2, plus 2, plus 2, plus 2. You might recall it's like how many D's are there, where D is for difference. And that'll tell you where in the sequence you are. So 11 is just the first term, which is 1, plus 5 D's, or 5 2's. So 1 plus 10 times 2, or 5 times 2 is 11. And that would be the formula for whatever term in the sequence we want to find. A geometric sequence is a lot like an arithmetic sequence, but instead of adding a bunch of D's, we're actually going to be multiplying by a bunch of, quote unquote D's. But in this case, we actually don't use the letter D. We use the letter R. R being for ratio or something. So we just keep multiplying by the same amount every time. That's what makes it a geometric sequence. And what it means is you get what's the nth term in the sequence? It's going to be the first term times how many r's? Well, n minus 1 r's. It's a lot like the arithmetic sequence. Instead of plus n minus 1 d's, this time it's going to be times n minus 1 r's, if you will, but it's the same thing. So here are a couple of really basic examples here. So 2, 4, 8, 16, 32, so on and so forth. Well, it's just going to be, what term in the sequence is it going to be? Well, it's going to be 2 times n minus 1 2's, because it keeps doubling every single time. All right? And likewise, you got 1, 5, 25, 125. And I'm telling you it's a geometric sequence. Well, it's going up by a factor of 5 every time. So it's going to be 1 times n minus 1 5's. All right? So not too different from what we're used to. I believe this one is going to introduce a couple of key formulas here that we really ought to be familiar with, but neither here nor there. This first question is not that bad. So fill in the missing terms in these geometric sequences. All right, I just realized I don't have my TI-84 out, so got to fix that. Now, we got 6 to 24 to 96. And you want to know, well, how much does this keep increasing by? It keeps going up by a factor of something. What is the factor that it keeps going up by? What does this keep getting multiplied by, in other words? Well, there's a very easy way to figure that out. All you got to do is just take any term and divide it by the previous term. And that'll tell you what it keeps getting multiplied by. All right? So in this case, I could just go, all right, well, 24 divided by 6 gives me 4. So it keeps going up by a multiple of 4. In this case, all I need to do is say, all right, 96 times 4. Presto changeo. All right, so 384 is the answer for this one. Okay, now this one they put it right in as the second one. So you might be thinking, uh-oh, this could be really bad, but it's not. All I need to do is take this term and divide it by this term. In this case, all I need to do is say, okay, well, 64 divided by 32, that'll be the thing on the top. And 27 divided by 9, that'll be the thing on the bottom. So as a part of our fraction here. So let's see, 64 divided by 32. So the numerator is 2. And 27 divided by 9, all right, 27 divided by 9 is 3. So this keeps getting multiplied by 2 over 3 every single time. All right. So what do I put here? Well, I got to take 8 and multiply it by 2 over 3. Now, on a TI-84, it's not going to give you the exact answer here. So, because they want a fraction, they don't want a decimal. But let's actually just punch it in and see what we actually get. So 8 times 2 divided by 3, 5.33333. Not terribly helpful, is it? But that's okay. So all I need to do is just say, all right, well, 8 times 2 over 3, I could just multiply across the top and multiply across the bottom. So really, this is just going to be 16 divided by 3, because 8 times 2 is 16, and then it's just going to be over 3. So all I need to do right here is just write 16 over 3. That'll be the second answer right there. All right, now for this one, fill in the missing terms. Ooh, this one's juicy. It doesn't actually tell you the first term. So how do I do that? Okay, well, all I need to do to find out the R here is just take any term divided by the previous term. So let's take 18 divided by negative 6. Whoa, yeah, let's try that again. 18 divided by negative 6. Okay, it keeps getting multiplied by negative 3 every single time. Okay. So what times negative 3 will give me negative 6? Right? That's what I need to know. So let's do the algebra here, okay? So let's take the second term, which is equal to the first term, times 1r. All right, so let's just do some basic algebra here. The second term is just equal to the first term times r to the 2 minus 1 power, or just the 1 power. 2 minus 1 is just 1. This is a perfectly good way to figure out what u sub 1 is. U sub 1 is the thing that we're looking for, right? Well, the second term is negative 6, and we know that r is equal to negative 3, right? So really, this just becomes negative 6 is equal to u sub 1 times negative 3. Yeah, so just plugging it in here, negative 6 is equal to u sub 1 times negative 3. Obviously, I can divide both sides by negative 3, and u sub 1 is going to equal 2. All right, there you go. 2 times negative 3 is negative 6. Negative 6 times negative 3 will give you positive 18, so on and so forth. So it's possible to have r as a negative value. It would be totally fine. Okay, now the second part of question 1 says, generate the first 5 terms of the geometric sequence given by the rule. Start with 1, multiply each term by 2 to get to the next term. Okay. I mean, I don't need a calculator for this, do I? Let's do it. 1, 2, 4, 8, and 16. I'm just doubling every time. Easiest part of the entire question. Okay, now this one says start with negative 7 and multiply by negative 7 to get to the next term. Well, I mean, we know we start with negative 7, so that's not a problem. Let's see. What can I do to make this easier on myself? You know what I'm saying? Um, well, I can do this the easy way, can't I? Stat, edit, and I'm just going to go 1, 2, 3, 4, 5. And let's just let's get the big view here. All right. So I did stat edit. I went to L1, 1, 2, 3, 4, 5. This is assuming, of course, that you have a TI-84 or something at your disposal. Okay, and I want to generate the first 5 terms of this geometric sequence. Well, why don't I just use my formula here? This one. This is equal to the first term times r raised to the n minus 1 power. Well, the first term is -7, and it keeps getting multiplied by -7 to the n minus 1 power. Okay, check it. So I'm going to actually go up, highlight the name L2, and I need the first term, which is going to be -7. And we're going to multiply this by, open burrito, -7. And we're going to raise this, that's the caret symbol right there. We're going to raise this to the n minus 1 power. In this case, n is going to be L1. All right. So let's pull up L1 by going to second list. Yep, you hit enter for L1. Nice. And it's going to be -1. You come back down and you hit enter. Piece of cake. There you go. So that's an easy way to just get all of the numbers down without even having to try. It says you are allowed to use a calculator. If you have a TI-84, you absolutely can. So let's just type this in now. 49, -343, 2401, and -16807. Now, if you didn't have a TI-84, well, you're just going to have to go -7 times -7, and you hit enter, and then you just keep going, times -7. Whoops, that's wrong. Oh, it's because I typed it on my keyboard. All right, fine. -7 times -7. All right, times -7, and then you'd write that down, times -7, then you write that down, and you just keep going like that. If you want to do it that way, that's fine, but you know, if you wanted to save yourself a lot of work and pain, you know, this is another way to do it. So, you know, another way to think about it. Piece of cake. All right, moving on to the next part of this first homework set. Pretty easy. Find the rules for these sequences. When they say rule, they really want to know what the formula is here. Okay, so not bad, not hard at all. So let's see, find the rules for these sequences. Well, it says start with, what's the first number? 13. Okay, what do you multiply each term by? Well, I mean, you could just take any term and divide it by the previous term, and it'll tell you what the answer is. So let's pull up our calculator. I guess we don't need large display anymore. Quit and clear that out. All right, how about 26 divided by 13? 2. So you multiply each term by 2. So easy. All right, this one says find the rules for these sequences. All right, you start with 50 here. Multiply each term by, well, let's say 5 divided by 50. That seems pretty fair. So 5 divided by 50. And you get 0.1. That's what you multiply everything by. So you multiply everything by 0.1. In case you guys are wondering how I'm figuring out r, well, it's not bad. So let's take this formula up here. It's going to be u sub n, and is going to equal u sub 1 times r to the n minus 1 power. And why don't we make it like 5, all right? So instead of u sub n, we'll say u sub 5, something like that. All right, so let's say we got the fifth term. It's going to equal this, which that 5 minus 1, that can simplify down to 4. All right, cool. And why don't we take the previous term, which is u sub 4. That's also going to be pretty similar. So if we say we took the one right before it, which is the fourth term, u sub 1 is equal to all this, and let's divide both sides. I could use a new page, I think. So let's get a nice clean page. Let's take this term and divide it by the previous term. So what are we going to get? So u sub 5 and u sub 4. And we'll have u sub 1. I could just copy and paste this. No need to work hard. All right, so let's take any term and divide it by the previous term. Well, as you can see, stuff is just going to start canceling out here, right? Cancel, 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 cancel. So first of all, the first terms here, those cancel. And R4 over R3, what does that equal? That equals R. So if you take any term and divide it by the previous term, you're going to get the R value. That's the thing that we're looking for in these questions. So you could just say 5 divided by 50 or 0.5 divided by 5. It doesn't matter what term you use because the first terms are going to cancel out and you're going to divide out all these R's and be left with just one R, which is which R here is this case is 0.1. Easy peasy. Now, in a growing bacteria colony with 104 cells, every minute each cell in the colony splits into 2. I am no biologist, but I do remember my high school biology class. I think that process is called mitosis. All right, so find the rule to describe this scenario. Okay, well, you start with, let's see, colony with 104 cells. I guess you start with 104. And each cell in the colony splits into 2, meaning it doubles every single time. So we multiply each term by 2. All right. How many cells does the colony have after 7 minutes? Okay. Well, that's pretty easy. Let's use our cool formula. Recall that the formula is this one. It's the first term times n minus 1 r's. Okay, so, well, the first term is 104. And we're going to multiply this by 2 raised to the n minus 1 power. Well, n here is 7, so 7 minus 1 power. 6656. That's how many cells are going to be in the Petri dish after 7 minutes. Huh? What did I get wrong? After 7 minutes. I don't think that's correct. Uh-oh, I don't think my MyiMaths is correct here. I don't think this is right. Nope, I don't think that's right. let's do this the good old-fashioned way here, because I'm pretty sure that's wrong. Yep, 6. I think someone programming the website might have made a little mistake. All right, let's highlight, let's prove someone wrong, because either I'm wrong or they are wrong, and I don't think it's me. Okay, so here we go. The first term is 104. Okay, we're going to multiply this by 2, and we're raising it to the L1 power, so second list L1 power minus 1. Yep. So as you can see, at the 7th minute, we're going to hit 6656. So I don't know how they got that answer there. I'm not sure I agree with that. Well, anyway, if you come across this question, I guess I guess you just have to take it to the 8th term, multiply your last answer by 2 for the sake of credit here. That's kind of disappointing. Anyway, that's pretty good. Let's move on to the next thing. All right, moving on to the next thing. So geometric sequences 2. All right. This one says find the next 3 terms of this sequence. Do not round your answers. All right. Well, now we know what we're doing, right? It's going to be, the first term is 20, and we just need to find out what the r is. Well, the r is just going to be let's say 6 divided by 20. All right. So let's clear out of here. 6 divided by 20, and let's hide our large display. Come back, TI-84. All right, so we keep multiplying by 0.3. All right, so let's see, 1.8 times 0.3, so 0.54. And let's multiply that by 0.3. 0.162. It says do not round your answers, so okay, I'm not going to round my answers. And let's multiply that last answer by 0.3 again. Okay, 0.0486. Cool. What is the common ratio? Of course, we already found that out, 0.3. What is the formula for the nth term? Well, the nth term is the first number times n minus 1 r's. In this case, the r is 0.3. So that's easy. All right, now work out the first 3 terms of the sequences with these nth term rules. Use q for the square root and put your answers in simplified surd form, meaning they want a radical and they want it as simplified as possible. Okay, not bad. Well, the first term here is obviously 7. All right, because, you type in 1 here. 1 minus 1 is 0. The first term is just 7. Okay, well, what's the second term? The second term is just going to be 7 times the square root of 7. So 7, you type apparently the letter Q for square root, and then 7. All right, now this third term is going to be 7 times the square root of 7 times the square root of 7. All right, but the square root of 7 times the square root of 7 is just 7. Okay, so 7 times the square root of 7 times the square root of 7 is just 49. So the answer here is just going to be 49. Piece of cake. Let's see. First term here, obviously, there it is. It's looking at you. If it were a snake, it would have bit me, right? Let's multiply this by -2. So -2 times -2 is 4. 4 times negative 2 is negative 8. Piece of cake. All right, now here we go. The second term of a geometric sequence is 2.5. The third term is 12.5. What is the common ratio? Well, okay, 12.5 divided by 2.5. Whoa, whoa. 12.5 divided by 2.5. 5. There you go. Let's multiply that by 5. Okay, what is the first term? Okay, well, I think I already have it up here, don't I? Didn't I do this just now? Yeah. So we got the second term here. We got our ratio right here. And we need to find out what the first term is. Well, the second term, recall here, is 2.5. So let's type that in. Okay, and the ratio here is 5. Okay, so 2.5 is equal to u sub 1, which is the first term, times 5. What's the first term? Well, you divide everything by 5. 2.5 divided by 5 is 0.5. So there you go. 0.5 is also a half. And that's it. Nice piece of cake. All right, and moving on to question 2 for geometric sequences 2. Find the next two terms and match the rules with the sequences. All right. Now, as you can clearly see, it's not geometric sequences per se anymore. It says recognizing mixed sequences. So it's going to have some fancy terms, in other words. I recommend starting with the blue numbers here and figuring out where each of these go. So this one says the nth term is 8n minus 1. Let's figure that one out. All right, well, what's the first term? Let n equal 1, so 8 times 1 is 8. 8 minus 1 is 7. The first term is going to be 7. The only one here that makes sense is this one. So that means that's got to go there. And while we're here, we might as well figure it out. So that's the first term, the second term, the third term, the fourth term. All right, well, 8 times 4 is 32. 32 minus 1 is 31. All right, how about the fifth term? All right, 8 times 5 is 40. 40 minus 1 is 39. There you go. Let's do this one. All right, triangle numbers minus 1. Triangle numbers we didn't go over in class, but they're not hard. I just quickly did a Google search for this cool image. These are the triangle numbers. In other words, you know, you're stacking a bunch of cannonballs on top of each other, and you know, they're going to form triangles or equilateral triangles every time. 1, 3, 6, 10, 15, 21. All right. Now, this one says, so the first term is 1, which means that but this is the triangle numbers minus 1. So the first term is going to be 1 minus 1, which is 0. The only one that makes sense out of here is this one. So let's click and drag that there. Now, triangle numbers minus 1. All right. So 1, 3, 6, 10, 15. Let's just 1, 3, 6, 10, and then 15. And now from each of these, I'll just subtract 1. So that and that. Now, I don't know when they generate this for you if you'll have the same as me, but you can just quickly do a Google search if they give you something weird like, I don't know, the Fibonacci sequence or something random like that. You can just do a quick Google search just like I did, and it'll show you what sequence you need. All right, double the last term and add 10. Okay, so it doesn't tell me the first. It doesn't tell me the first term at all. But let's see if we can't find out which one it is. All right, well, 4 to 18. Well, if I double 4, I'll get 8. If I add 10, I'll get 18. All right, that might have been a lucky thing. Let's try it again. So let's double 18, which is 36. 36 plus 10 is 46. Yep, this is the one you want. So let's just pull that right there. All right, now let's double 46, which should be 92, and we'll add 10. 92 plus 10 is 102. All right, now let's double that. We'll get 204. 204 plus 10 is 214. All right. Now this one says the nth term is 3 to the n power. Well, that means if I said let's let n equal 1, then it'll be 3 to the 1 power or 3. The only remaining ones here, it's going to be this one. So let's just put that one right there. Okay, and it looks like I just keep multiplying by 3 every time, right? So what's 81 times 3? Okay, 81 times 3 is 243. Remember that exponents, this little n exponent here means I'm multiplying 3 to itself n times. So 3 times 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 3 n times. And that'll tell me what term I'm at. Which means I could take 243 and multiply that by 3 one more time, and I'll get 729. So 729. So far, so good. Now, all right, the nth term is n cubed plus 3. All right, well, which one is it? Let's let n equal 1. So 1 cubed is 1. 1 plus 5 is 6. Which one of these seems to work? This one. Okay, so let's click and drag that there. And, okay, that's 1, 2, 3. Let's do 4. All right, burrito, 4 cubed plus 5. So the fourth term should be 69. And let's do the next one, which is the fifth term. 5 cubed plus 5. I like to burrito everything just to be super careful. 130. There you go. And of course, by elimination, it would have to be that one. Multiply the last two terms. Okay, 2 times 2 is 4. 2 times 4 is 8. 8 times 4 is 32. Not bad at all. Right. I hope you found that this video was useful. Looks like we are rapidly approaching the end of the year, and I hope you all are still staying safe and following all CDC guidelines and whatnot. And if you have any questions about anything, please let me know. Take care and have a great week. Bye-bye.